There we go. We're live. Let's go. Okay. Well, welcome back. Welcome back, everybody. Welcome back to the game engine development stream. Before we get started with the coding, as always, we'll have a little bit of a talking segment. First of all, how has your day been? Mine has been pretty good. Yeah, just the usual. Went to work, came back home, made some food, ate, just finished eating, feeling fulfilled, feeling a bit slow. And I'm ready to program a little bit on the game engine. But before we do that, let me first get this actual YouTuber stuff out of the way. Share the link. There we go. That's all done. Come on, load. There we go. Let's check if everything is working. Everything else seems to be good. Okay, anything on my talk list? I don't think so, no. Nothing happened. Oh, there is something, though. We need to talk about something. And that was the disaster that was last stream. Honestly, like, it wasn't technical issues this time, it was just me being stubborn. Okay, so I will get more into it when we get into the coding, but basically I was stuck on something for like an hour and a half, basically since the beginning of the stream. I was stubborn enough to not to want to do it my way, when that would have never worked, so I have to backpedal a little bit today. If you were here last stream, you do know that it was about memory operators, and the goal here, which will still be the goal for this week's stream, is to detect memory leaks in our codebase. And I just couldn't. I mean, I wanted to do it one way, but it was ever impossible, and I had it in my mind somewhere that it was possible. I did check the source that I thought, because last week I said I had a source in mind that actually does it correctly, like does it the way I wanted it to do it. It appears it did it slightly different. So yeah, that it is gonna be the way I'm gonna implement it. Didn't look at it too closely, but we'll stumble our way through it this time. I will trust everything now. Don't get stuck in my ways. That's a humbling lesson, right? Either way, I think we're about ready to jump into things. Oh god, it's warm here. Okay. Yep. Seems all correct. Let's do this. We can switch over to the programming side. Yeah, okay, that worked. I was doubting that for a second. So as said, we are gonna be looking at memory leak detection today. And if you go take a look at the code, well, if we have some more time, then we'll continue down the list, but we'll focus on memory detection first. And if we check out how we did it last week, I'm pretty sure we have our memory operators here. So I wanted to do it this way, by having a define that says, hey, this is new, and then do something. This would never work. We need to overload our new and delete operator. So basically the only thing this is gonna do is exactly as it says. Gonna just do new and delete. We're not gonna do that. We're just gonna call delete on it. However, that begs the question, do we actually want to have the defines? And I think that's actually a good thing, which I'll explain once we get into it. But basically we could also add more information here. We could add some more extra information. So I do like this, but we're just going to implement them as new and delete. And I think that would be the way to do it. And then inside our memory manager, or actually, can we do it in memory operators? Yeah, it is probably better to do it here. We are going to overload our new and delete operators. How we're going to do that? Good question. I'm going to look up the new and delete operators. C++ memory operators. Operators, and I can't type again. Should be this. It's these. So we need to overload all of these functions, which is a lot. We can also do these, which is user defined ones. Hello, welcome to the stream. We're making a game engine, and today we're gonna focus on making sure that we are not leaking any memory. So overloads are replaceable. The effects of default attempts to allocate requested whenever they involved calls to malloc is unspecified. If the attempt is successful, to support the allocate starts. Yeah, so we're gonna do this. And this is how it does it. We need to overload all of them. I'm pretty sure we need to overload all of them. We could do class specific or not do that. I'm not sure if you can overload them in a namespace. That would be nice. But I'm pretty sure it's global. So we're gonna globally overload these 8 first ones. And then we have everything else. Yes, C++. I think that's it. User-defined placements function. Yeah, so then these two, I don't know what it is. Size, found pointer, non-allocating. Oh, this is when we already have a pointer. Don't worry about that. Okay, and then we can do these, which will also be useful. And then class specific, we're not gonna worry about that. So we need to do these 8. So let's do the first 4. So let's start with this one. There we go. Boom, that's 1. Second one. That one. Third one. Alignment value, god. Okay, we're just gonna overload them. There we go. I don't like the layout of these, so let's also fix that a little bit up. Should just do it like this. Delete those. Delete that backslash, that. Alignment. Remove this extra space here. Add an extra space here and here. So globally overloaded memory operators. There we go. That's all the news. And then we also need all the deletes. This is just a new. So we need those. We probably need them no except. Probably. Yeah, we need those as well. So we're gonna do this. And then boop. Okay, and then we'll with a no throw tag. And all of the others as well. Is it just the same ones but no throw? We can actually do it way easier then. Let's just do it this way. No throw tag. Whoops. No throw that tag. You just started C? Well, good luck to it. Good luck. It's not as simple as people tell you it is, but it's very cool language. You can do a lot. I like it. C++ looks a little bit weird. Well, it's very similar, just has classes and a little bit more stuff. So if you get used to C, you should also get used to C++ at some point. These are all no except since C++ 11. So we also will do these no except. There we go. I think that's all of those. We don't need these yet. We don't need class allocators yet. Called to the stem replacement new expressions performs no action and returns a pointer and modifier. What the hell is a placement new? Oh, great. There we go. Whew, that was a lot of spam in the chat for once. Great. Damn it. Whew. Okay, we got that's the first. Okay. The standard is weird everywhere. Well, I don't use it that often. It's just the standard library allows for a lot of things to already be there. We're not gonna include memory manager here though. That would be weird. Okay, so we got all of these. We will implement them in a second. Oh boy. Okay, that's all that. Do we need to do the placement? No, wait, can we? If this function is called through placement, attempts to allocate the number of these are new expression to allocate memory which we replaceable. The standard library provides default implement for the effect of defaults. Calls specific, performs no action, and returns that. Overloads are replaceable, so that's what we did. And we will need to have the exact same result, so we'll leave this open. Hello, what are you gonna do? I'm making a game engine. Currently focusing on memory operators, so we're gonna implement some memory operators. That way we can find out if there's any memory leaking, if we're saying to the operating system, hey, I'm gonna use some memory, and then not giving it back like just, yeah, spoiled child, basically. Okay. Attempts to that, then returns operator new count, which weird. Okay. Either way, I'm pretty sure these are just the same. You can use using namespace, which means okay, but using namespace is actually not a great idea. Mainly for the reason that if I define the same type, you'll have conflict. So having the namespace is actually better. Why did that one survive? Okay, anyway. These are all the functions we need to implement for new. We'll also open up a new one for delete operator and C++. Okay, and these, I'm pretty sure it's the same thing. It's gonna be 8 of them. Usual default allocation, deallocation. Oh, there's more of them. Uh-oh. Delete void pointer, delete void pointer, throw? Why is there a throw and a no accept? Interesting. Oh, that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's see. Oh, there's a lot more. Deallocation, replaceable, 1 to 12. I'm using DirectX 12. Declared in each translation unit, even if the new header is not included. Yeah, exactly. I don't know. I mean, I have an idea of what throw is. But just otherwise, it claims the storage allocated earlier by that. Calls delete that. Same as that. Calls yada yada yada. Okay, so there's 12 delete operators we need to implement, which is gonna be great. We can find out what the throw does in a second. Actually, let's look at it now. What's the difference between the throw and the non-throw version? Baseball function, calls delete. Pointer that, arguments. All the functions are no except true unless specified otherwise in a declaration. If a terminates by throwing an exception, the behavior is undefined, which is weird. So we should have all of them no except. Technically, we should never be able to yeah. I don't know what it defined twice. Let's see what the throw does. Because there needs to be a better explanation pointer for this. No, that's just that. That's wrong. That's Googling skills, man. Throw C++ memory operator. Throwing exceptions operator. Yeah, I know. Okay, just find it in here then. Jesus, throw. Okay, so it just specifies it here and then nowhere else. Just gonna define them as no except, because throw seems weird. That's just undefined behavior. right? Yeah. And then global replacement, so we'll do all of that. Class specific overrides we don't need. Okay, copy paste time. So the no accept versions of these, and of course they have spacing that's weird and doesn't align with what I'm doing, so we're gonna have to that one, close. Void pointer, that's the delete, so that's actually the counterpart of those two. This one, no accept, that's the aligned variation, so that's number one. Okay, it's gonna get more interesting than this. This is the delete, but with for an array. Okay, next one. Oh, delete with the size. Oh, that's interesting. C++ 14. Is this still used? 5 and 6? Does it say deprecated or not? No. Okay, then it's still used. Yeah. You're talking about exceptions. Exceptions are mainly slow, which is why we don't use them. And on top of that, they're also not that great to use when you're combining different languages together, because standard exceptions, like the C++ exceptions, are different from exceptions in another language, which is why mostly it's communicated with error codes. Which, I mean, famously, you know, like all the HTTP error codes, like a 404 error when you don't find the page or something. That's from those. Okay, there's two more with the size exception, but I'm guessing it's with the aligned tag. Okay, so there's just two extra with the size tag. Okay, interesting. I'll have to write the read the documentation to figure out what exactly these need to return. Okay, and then I'm pretty sure we just do the same thing, but with a no throw tag for that, for that, for that, and for that. But not for the size one, which is cool. So it's just these again. Whoops. And then this. And here, whoops. I apparently, whoops. Come on. Didn't copy the comma. Again, come on. Boop, boop. Why is there, oh, I removed the pointer here. Delete. That's a no throw tag. Okay. That's all the definitions. And now we need to implement them. Will be interesting. So we need a CPP file. Yes. Yes. Okay. How do we do that though? Okay. We need an extra file, so I'll open my manager here. We need to go to engine, corelab. We need to add an extra file, which is memory operators.cpp. Here we go. Yes, I want to create a new file. I know what I'm doing. I should have. Okay, anyway. Okay, and then CMake, and here we're gonna duplicate this at CPP. We'll need to rebuild. Oh, let's just rebuild this one. Rebuild. Where's it? Rebuild. Selected projects. And that should have added our file. There we go. And since we copied it, everything is in there. We need none of this. There we go. Include memory operators. Okay. First one. I'm just gonna copy. Why is size T not included? Oh god. Fine. This should be at the top of the file. Align value. I'll enter which one. Oh, let's just include new. That will actually way better. Yes, okay. That's apparently not how you spell globally. Oh, I forgot it. L. Okay, first one. Copy this over here, paste it in, and then we're gonna implement it. What are you doing? This. Okay. What does the new operator need to do? Well, the new operator needs to attempt to allocate requested storage when the attempt involves a call to malloc or aligned alloc is unspecified. If the attempt is successful, returns a pointer to allocate storage. New alignment. Otherwise, if currently no new handler is installed, throw bad alloc. Otherwise, call the currently installed new handler. Invocation. Okay. So we just do a void pointer PDR. We start at no pointer. Actually, we can start with a malloc, I guess. Account. Which will allocate memory for us. Then if pointer equals no pointer, then we are probably out of memory. So we will actually need to look up what malloc does now. Okay, yeah, that's actually very interesting. This is actually exactly what we need here, right? So operator new with the size t, we printf, that's not what we're gonna do. If the size is 0, we just return a null pointer, which is fine. If count, count equals 0, I'm gonna just return a null pointer because we don't need to allocate anything. Okay. Sure. Yeah, we will make one in the same scope, don't worry about it. So we malloc, if pointer is no pointer, then we return standard bad alloc, I guess. Oh, that's a throw? Oh no, that's not what we're gonna do. We're just gonna return a no pointer as well. So we can just return pointer, but we're gonna assert on it. Or actually, we're gonna throw an... Yeah, you know what? Let's throw the bad alloc. Yeah, there we go. Return no pointer is actually also not true, so let's just assert for it. Because we always want to avoid it. Assert, which we will... Whoops. Don't know what did all that. HB assert, then we're gonna assert that count does not equal, well, is bigger than 0. I was gonna say, I'll enter. Trying to allocate invalid amount of bytes. Boop, and this will print out the number of bytes that we're allocating that's wrong. Okay, so we're gonna do that. If that, otherwise return pointer. Pointer, there we go. Let's do it differently. Let's do it this way. DR, and then we're gonna return bad alloc here. We're not gonna return it, we're gonna throw it. There's nothing we can do about this but I do want to make sure that we assert before we do it, so we know. So let's say HP assert always false, because we'll always want to trigger it out of memory. That's it. That's our new operator. Very simple, right? Well, we need to do that, a lot more times, but it will get easier. Second one is the same, but with this. Also, before I forget, if we succeed in it, we need to say that we have our ls memory manager. Ls, what am I saying? HP memory manager. Get instance, because it's a singleton. Yes, I know it's a singleton. That increase mem count with count. Technically, we could actually do this in the beginning or always. Doesn't really matter. But I think it's fine by this. Then same here. I'm pretty sure we do the same thing, right? 2 returns operator new. Okay, so we can actually do that. Return, can do the same thing here. Operator new count, there you go. They're still complaining about something, but I think it's the delete operator, so we don't need to worry about that for now. Then the next one, 3, is same as 1, except that the return search is aligned to alignment. Okay, so now we need to do alignment. We need to take alignment into account. Pretty sure the easiest way to do that is actually make the aligned one and then align this to the default value. Okay, so that with alignment, I should have just copied this function. And the alignment value, can we just malloc aligned or aligned malloc, is it? No. What's malloc aligned? There was something here. There's an aligned alloc. Okay, where is this located? Okay, that's fine. Align alloc is in this header. Okay. Need that header now. Apparently it's still not in there. What? Okay, let's look at malloc then. Pretty sure malloc is. Somewhere in here. Malloc, there we go. Malloc size, okay. Is there no... what? C++ documentation, there we go. If any allocation returns a pointer to the lowest byte, at least strictly as max align. See, I could do aligned alloc, but I don't know why it doesn't find it. Let's copy this. I probably typed it wrong. I did not. Interesting. So how do we allocate this. If size is 0, the behavior is defined, no point may be returned, or some no point may be returned that may not be. It has to be passed free. The following functions are required to be thread safe. Library operator new, delete, user, alloc, malloc, aligned alloc. So this function exists, so why can't I find it? Copy this, include this, aligned alloc. Oh, I'm using 20, so there it shouldn't be I know it's only from C++ 17, so the standard should not be the issue. That's why I'm looking at the documentation to see if it was deprecated or removed, but I don't think it was, because it's since there's nothing else. I mean, I can skip alignment for now. I don't really need it, because I'm not gonna optimize it that much for now. I'm not really interested in doing cache line optimizations at the moment. But it would be nice to already have it sorted, so I don't know, because it's just or is it .h? No, it's not. Just to... Okay, that one doesn't exist. Oh, let's check the standard. Okay, standard is not there. It's gonna be here somewhere, so let's find it. There we go. You 20. 6 standard. Yeah, that's all I need. Is it just because I also need to put this in there? Don't tell me. Okay. No, it's the other way around as well. Let's look at the C one. Because the C one is just in this one. So I can just probably use that one instead. Oops. Does it find it? Apparently it still doesn't find it. Probably because it's not in a namespace. Yeah, of course. Okay. Well, I could just do malloc and then aligned alloc. Oh, it still doesn't find it. Okay, never mind. I have that one. I'm using it. It's the aligned alloc that's not working for some reason, which is weird. I mean, let me just try and... I mean, I could try and compile it, but I've not implemented any of the functions, so that's fine. This should... Well, we'll just assume it works. And technically, instead of doing all of these, I could just call the align one. And that will make it a little bit easier to maintain. So for this one, I could just call the align one. Like so. Wait, hold on. Okay, yeah. So I could just do operator new count, comma, and then what's the default alignment? It was in here somewhere. This one. There we go. Return. Unsigned candidates considered unsigned parameter align value. Great. So what is this? Great, just show me this. Yes. possible, which is that, and then okay, let's just wrap it then. Line value like so. There we go. Fix that one. This one will be the same, but operator new. This one. Oops. Right. And then the last one, which is this one. Again, very simple. Just gonna do that, and then we're gonna call this. Boop, done. Great. Technically this should just be this. Yeah. That's half of them done. Yep. This should compile at some point. We'll see if it compiles or not, but okay, the node throws. What do the node throws do? Same, except if a call returns normally, result of that call, otherwise return a null pointer. Okay, so that's the same as I do, but without the throw. So we'll do this, copy all of them, paste them beneath, and then we're gonna return null pointer here. And then we are gonna make sure that we have the no throw tag on all of them. That's what's gotta be different about these. Oh, and this one, that's a good catch. This needs to be alignment value. And tag. There we go, out of memory. We return a null pointer, don't worry, this one, like so. The tag we don't use. That one we do use. So these as well, to throw, and then we're gonna put the tag in here. Same here, that, not throw, and then the tag. And before I forget, this alignment value needs to be filled in. Like so. Okay, so we got the both aligned allocs being wrong. Good. Technically, I don't need this or this one. And I think that's all the news. Redundant. Redundant operator declaration. What? Yeah, it's not redundant. It's what I'm overloading. Oh boy. Okay. Now time for all the deletes, I guess. Good. That's all the news. We increase man count in all of them if we allocate something. Then the deletes. Okay, deletes. How do we do the deletes? Operator deletes. We will go through here. This is what we need to call by delete expression. Yeah, no, this is what we need to. If pointer is null, do nothing. Otherwise, retain the storage allocated area by calling free. So the delete, copy. Well, let's first of all do this one. Same as one. So this is gonna be the first one we implement. I don't think the no except needs to be in there. How do we get the size though? Does 3 allow me to show the size? Damn, it's gonna be difficult then. because we don't know what type it is. Oh, these do have the size though. But I don't think that's the default one. Delete void pointer size. The array one's completely not sure how to do those. Okay, and new that. I was looking at the wrong ones. Okay, that's delete. We don't know how much memory it is here. It's very interesting. How would you know? Oh, I guess we can always call delete with the size operator, maybe? Because of size up? Difficult, very difficult to say. So we should call free size, doesn't matter, alignment value means that we need to call free aligned, I guess. Aligned free. Pointer, there we go. And I'm guessing aligned free also doesn't exist. Aligned alloc, which will need to be called with does it say? Divide memory liquidity return point. Okay, just be free. Okay, so we can just do free. Oops. There we go. If it's not a null pointer. If pointer equals no pointer, then we just return. Easy. Then we're gonna decrease our memory count by so much size. Size stays the count, right? And then alignment value we're not even gonna use. Great. Where's my delete operators here? Did I forget the... No, okay. Interesting. Yeah, there's 24 to implement here, right? Okay, that was a delete operator. Do I need to put no except here as well? Is that what it's complaining about? Okay, so the no excepts need to be no except. So, interestingly enough, it's only one of them. All of the no throw tags always need to be no except as well. So no throw tag, no except, you as well, no except, you as well, no except, and you as well, no except. 1, 2, 3, 4, yeah. And then these are the normal 4. Wait, why do I have 2 implementations? Oh, the no except type implementation and the other one. Yeah, makes sense. Never mind, said nothing. Okay. That was this one. We also need this one. Just the aligned one and the signed one. We actually need the size one. That's the one we implemented, right? The aligned value one? Yes. Okay. And so now let's do all of these. Well, let's just copy all of these first. They should be in between here. Actually, let's do a little bit of quick magic. Oh, let's do 4 at a time. And do that, whoops, this, do that, enter, there we go. And then can we do that? Perfect. Then escape. Boom, boom, boom. Okay. What are we gonna do? We're gonna call delete operator delete pointer. We need the size though. Oh, we can actually just call a bit weird. Bit weird. Okay. Delete that, and then we're gonna do delete can never accept, right? Yes, all no accept. These can fail. I don't know. I don't like that they can fail, but oh well. We'll work with it. So we're gonna copy the alignment value, right? Yes. And same here. Actually, let's check how they implement the delete for an array. New delete array is just free as well. And it's also just size. Interesting. Because these are going to be the same thing, but we need the size now. I don't know the size. Size of pointer? Maybe? Probably not. We need to know, but I'm pretty sure we will get memory allocation issues now. So that will be perfect. Can test it out. I don't know why this is a bit annoying now, so let's just do it this way. That one needs to be after. There we go. I'm just gonna call this pointer size tag alignment value, sorry, alignment value, because we don't have tags here. Okay, that's that. And then these just have a size, so we can do choop, put it in there, and then have size, and then copy this again in here. Okay, I think that's all of them. So we do have all of these. Redundant, I don't care. So I'm pretty sure we can try and compile it now and see how many errors that will give. That's some. That's the exact one I was expecting. Aligned alloc. It's not found. C++ 20 align alloc. Let's type it in. Thanks. So let's see what it should be in there. How can okay, CMake. I'm changing my CMake. Let's see CMake, and then let's find C++ standard. Oh boy, that's too much. Let's just type it in here. Okay, so we have CXS standard, right? And then we can specify 20. Why is it? That's weird. Somehow it's cached. Okay, CMake standard. There's two properties, I remember. It's just allocation? Okay. Weird. CMake C is a standard. This is the one I'm setting. And this one. CMake C is a standard. Yeah, I have that. I can do this one, I guess. I'm pretty sure it's required and everything. I can put a C standard as well. Maybe that will do something. Let's follow this tutorial. Let's see what the tutorial does. Okay, so required version, executable, yada yada yada. That's all good. Version, main and minor, standard. See, it's doing the same thing. Just set the standard required to true. So what I'm doing, I can't put it to to 17. Okay, C standard. I could do that, yeah, that's fair. Okay, 17. There is not even a 7. There's not even a 20. Okay, I'll try that. That's true. CMake extension on. That's true. Can try that one. This one. Yo, put it on the next line. There we go. Let's put it on there. Okay, zero check, rebuild, selected projects. Let's see if CMake will say something. No, perfectly fine. See, so that's all fine. And then we can technically check properties. Let's see what the C++ standard is 20. Static library, C++ language. Let's see if we can set it to, well, okay, let's set the C standard as well and see if that does anything, but we'll need to set it to 17 because 20 apparently doesn't exist. Okay, rebuild. Okay, so now if you go to properties, that's, hey now, I just set inherited. Fine, required true as well for you then. Rebuild. Okay. Properties. What? Fine. Okay. I just put it to that myself. Let's see if we can build selected projects. It's still gonna complain, I swear. Oh, did I mess it up? That is possible. I have been known to make that. What? Oh, I forgot the underscore. You're right. Okay, so now that one should not be inherited anymore, but still, it doesn't fix the issue. Because I'm pretty sure now it will be set. No, it's still not set. Great. Okay, let's look this one up and see which one. And copy it. Oh, it's just C standard. No, that's correct. I'm not sure if that one actually exists. Oh, it does. So this is correct. This is correct. Extension on. We actually don't need this, I'm pretty sure. So let's keep it like this. Let's keep it clean. I don't know why it's not finding it, the header. So let's just it's MSVC. there might be something wrong with MSVC. It's not the first time. I hate MSVC. They have their own. Of course, they have their own. That is so stupid. Why are you like this, MSVC? Oh boy. Not happy about this. That is so bad. Sure. Okay, well, do I have a defined for this? I am not sure. I do have my compiler options. Oh, I should add a define to it, I guess. I don't want to do that. Oh, that's so bad. Oh boy, MSVC sucks. Okay, well, I know what I need to do now. So let's check the... I don't know which one it is. Platform, no. CMake have compiler options, maybe? No. Environment, this is the one. The environment one. Target platform. Yeah, it's not a C++ issue, it's a Microsoft issue. Platform Win32. Okay, that's the one I need to follow. Okay, so set HB compiler MSVC. Okay, so I need to add a define to CMake. I don't remember how to do that. So let's do CMake add define. Oof. Let's just add definitions. Okay. Fine. Thanks, MSVC. To switch to Microsoft specific stuff. Okay, and then we're gonna do add definition, and it's gonna be the HB MSVC. Well, actually, let's do this because that's better. There we go. That one. So now if we rebuild this, there we go, and then go back to our memory operators file, we can do an ftef, which I don't like doing. HB compiler MSVC else, and then endif. Oops. I don't know where this, I did look it up, but then I removed it. So let's do the, go back. Yeah, okay, where is this located? Oh, it's just with an underscore. Okay. Okay, let's do it using aligned alloc equals underscore std underscore align. That's probably without the std underscore align malloc. There we go. Oh, can't be used as a type. Boo. Fine. I can make it even worse than define align alloc stat else define it. Alloc as standard aligned alloc. There we go. And then copy this, paste this here, paste this one here as well. Oh, I put a semicolon at the end. Whoopsie daisies. There we go. That should do something at least. We'll see what goes wrong here. Pointer aligned that alignment. So it's 100 and then alignment. Oh, you... Oh my god. Yeah, that's true. But it's still wrong. So it should be count alignment. Count alignment, right? This here as well. And then this should be, what is it? Count alignment? Oh, okay, so let's do it alignment count, because I don't like Microsoft. Count alignment. And then I'm pretty sure the other one is the other way. This should be align malloc count alignment. Yeah, and what does it say? Cannot convert align value to size t. What? That's not what this. Oh, and we should definitely at the end of this file do an undefine aligned alloc. I don't think I need that. Try and compile. Pretty sure there's something wrong. Yeah, okay, so before we do that, let's just do this one. Let's use that and see if that works before we try and substitute it. That might have been a good idea actually. Count size t for alignment as well. Oh, you Microsoft, you fine. Oh, size t alignment. There we go. Everybody hates Microsoft. Just don't worry about it. Don't worry about it. Oh, we're still referencing it wrong. Oh, okay. Nope, that's actually correct. Thank you very much for catching that. That's why I enable all the warnings, people. It's to catch stupid stuff like that. We need to do the alignment in here. I'm pretty sure these are still wrong because we need to get the size somewhere from, but it's don't worry about it for now. Does it compile? Big question. It is compiler. It might work. It might work. It might actually work. Actually, in the meantime, let's check if we have our main function set up. Yeah, so we have our memory leak detection here as well. I'm pretty sure this is all set up. If you go here, we do increase and decrease. Okay, so let's see if we run it now. Oh, that was some kind of error. I don't know what error it was. Okay, let's see, debugger output. Yes. Great. That's fine. It's also fine. Use align free. Microsoft. Oh, shoot. Okay, so, you know the whole thing we did with align malloc? Well, let's do that again, but with aligned free. And then let's use aligned free here, which is probably just gonna be pointer. Or do we need for aligned free to use something else? Data alignment. Aligned free, okay. Void memblock. Okay, great. So they implemented like exactly the same probably. Okay, so align free with a pointer. We'll call pointer. Align free with a pointer. We'll call standard free with a pointer. And then we're gonna use this instead of new, align alloc. New words to delete. Standard free, nope. Aligned free, no, actually that's fine. Oh no, this is aligned. This needs to be this then. Do we always align? We don't have a malloc in here somewhere. No count. Align malloc. Okay. Compile. Boy, this is stupid. Thank you very much, Microsoft. Okay, we got a triangle. That is something at least. Let's check if we have any issues with... Okay, there's no issues with DirectX. So we got our triangle back. If I close it now, we have a little bit of memory leakage. A little tiny bit. Small tiny bit. Okay. Now I don't know how to get the size T1 because I'm pretty sure we are encountering it because we go through... Actually, we can put a breakpoint, right? We probably go into... That's the news. Where's the deletes? We probably go into... That's the new... Delete. We probably get in these. Like one of these. And these don't have a size. So I'm guessing the size, which is bad. Okay, we don't get in these. Apparently. Oh, that probably will be compiled out, won't they be? Ah, that's unfortunate. Okay. So we can actually remove all these breakpoints. Okay. Unless, of course, because I'll put a breakpoint in here. We always get there through... This is a size one. So let's see, we get through the size. We also get there through the size one, I think. Yes. Okay. Now on the delete, which is this size one. Size one. Again the size. Again the size. Size again. Size. 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 Okay, so this might actually work. And now we get here. So there is something that is leaking and we need to figure out what it is. This is gonna be interesting. So actually, I'm pretty sure we're done with memory operators at the moment. I mean, we might find some issues when we debug. So to start off, let's actually just compile this out. Run it and see if we have any memory leaks. We should have 0. So we are running it. We stop running it. Nothing there. Good. Nothing. Uncopy this. If we don't run or shut down or initialize anything, do we get there? Do we get any memory leaks? No. Good. Okay. So if we... Now we need to do all 3 at once, because I don't think we can do anything without them. So now it's gonna be a question of which member variable is it. This is gonna be interesting. So what if we only initialize the window and no rendering? Technically, I could add some more debug statements to it. So that's all that done. We only have a window, so we only show the window. Show, this is all done. And then we don't do any rendering. So we can actually just this. And then build and debug. Okay, so we got our empty window now. We close it. We have memory leaks. Oh no, this is my breakpoint. Never mind. We continue. We continue. This button. We have memory leaks. We have 64 memory leaks. We have 64 bytes leaking. That's interesting. There's something leaking in our window class. At least that's what I am thinking at the moment. So let's actually check our application. We have a window, right? This is a unique pointer. So this handles something that's that leaks bytes. So what I'm gonna do now is I'm actually gonna have some debug prints, because I am not sure. Basically we have this. I am gonna make those. How are we gonna make this easy? Okay. How to make this simple? Okay, we're just gonna check our allocations. So we're gonna do allocate here. So we should get here. No, we should get here, which is the increase, and we should get here, which is the increase as well, and a decrease, which is here. So now we need to make sure that they line up. Oh boy, we need to do this for like 1050 bytes. All right, so this is the first one, which we allocate a unique pointer, makes sense, which is our window. And we just create that. Okay, next. That was the only thing we allocated, just that. So then when we close it, we are decreasing it with size of 32. It is our unique pointer of our window, probably. It's not showing me which one it is, but it's probably the unique pointer of the window. We are increasing something else. Am I leaking bytes here? Oh boy. Do I increase the memory count? Oh, that might be... that's the issue, that you're a savior for spotting that. Hold on, let's check. Okay, so this is the new, which is increase. Yeah, you're right. I can already see it in the tab. You are so right. Thank you so much. Jesus, bad mistake. That would have taken me like 10 minutes to figure out. I would have read over that like so many times. Okay, so it's compiling, it's running. Okay, so we increase, get the window, we do this, we decrease, and then we report memory leaks again. So we increase it, which might be fine. Increase it again, increase it again. Okay, so how many bytes are we leaking now? Still leaking. Okay. Interesting. Now for the big question. So I increase, I decrease. Am I actually decreasing? I thought so. See, this is... I saw it calling the correct functions this time. Thank you for spotting that. That's great spot. I swear it would have taken me like 20 minutes to figure it out. Okay, so now we're decreasing again. No memory leaks. Oh my god, you're a lifesaver. Okay, so that is without rendering. Let's see if our rendering is correct. And I actually think I know for a fact that it's not. So we should get some memory leaks. App.run, which is fine. We just do render here. We uncomment this. We uncomment this. Could be strength view? No. I don't think so. Wait, hold on. No, I don't think it could be because it needs to be formatted. I'm not sure if you can format a string view. No, don't worry, that was not a stupid question. Because it makes the string at runtime, it can't be string view. Yeah, so we do have memory leaks. We have 64 bytes of memory leaking. I need to figure out where that 64 byte is now. I think I remember it was something to do, there was some array. So actually, let's go find our reference for HP new. Right, because that's the only ones we call in the solution. We call this. Oh, we're only using it. Okay, let's find new in the new reserve size, T new data. Oh, we're still doing new here. That's bad. This should be an HP new. I'm pretty sure that should be an HP new. It should be at least an HP delete here. But it should be okay. So this should be okay. Couple of things in our. I closed the thing. Okay. Base application. Core lib. Memory operators or defines or new can probably just be new. We don't need the data in here. Or delete, however, does need to be read, I think. Or actually it might be fine as well. So let's actually leave it like these for now. There's a reason to this. Don't worry. There is a reason we're doing this. But I'm pretty sure now we can just find HP new first, because we will need to fix that one to be just HP new like this. There we go. And then we're gonna find all the news we have, because this should be HP new and this should be HP delete. I think that works, right? Yes. We might need to revisit delete later on, but that's fine. Okay. We need to skip all the memory operators one. There's one for dynamic array. This is fine. That's also fine. That's fine. Did this one. That's memcopy. This is memory operators again. This is fine. That's fine. This is not fine. And this is probably the one that's gonna be giving us memory leaks. HP new. Okay, compile it. Let's see how many memory leaks we have now. Ooh, it's taking a while to compile. Where's my output? Oh, I was running it. Okay. Memory leaks, still 64. Yes. Still 64, that's weird. So we need to figure out where these memory leaks are coming from. So we have our HP's news to look at now. Oof, I don't know what happened there. These are all the news we do. So there could be this one. New data. We memcopy the data and then we delete the old data. Possible. What is happening? Is my internet dying? What is going on? You okay, chat? Okay. Let's just hope that was temporary. And then we equalize. Okay, so that's a memcopy. Yeah. This should be fine. We knew it. We get this. We delete the old data. I think that should be fine. And then this one. That was the same one. This one, I'm pretty sure is the issue. right? This is probably the issue. We are allocating this one, but we're never deleting this one. Just the shader. Dude, chat. Either connect or disconnect. Just don't. What the hell? Oh boy. I'm sorry, people. I'm not sure if it's my internet that's being an issue or whatever, but I mean, something is happening. I will just continue though. So we have m elements here, which now can actually not be in pointer array. Jesus. It gives me a notification every single time. You done? YouTube, come on. Behave yourself. Alright, so this is the leaking part. This is probably, if we check this, size of 32, it's perfect. We have 64 leaking. We allocate one of size 2, so that's 64 bytes. Okay, so in the delete, we actually need to create the delete here. And then we're gonna have to copy, paste this, DirectX 12 shader, delete. So let's remove this, move that, put a delete in front, which is this one. And then we're gonna say delete, HP delete, elements. Now, deleting a null pointer is perfectly safe. Don't need to worry about that at all. But we do need to do this. There we go. And then if we run this, this should probably fix our memory leaks. And that's good. That's what I wanted to do this stream. Okay. We got this. How's my stream health doing? Is it okay? Sure. We'll assume it's good. Boop. There we go. Ooh, we still have memory leaks. We have less though. Huh. Interesting. We have 8 bytes less. So, am I deleting elements correctly? Yeah. What? Put a breakpoint here. That, F11, F10, F11, F10. Huh. So that works. Yes. Okay, hold on, let me... 8 bytes? Oh, it's a pointer. Huh. Interesting. I'll come back to you. Okay, so, interesting about C++, it is very, very low level, which means you get a lot of tools you can use and abuse, but it also means you have a lot more complexity to learn. But it gives mostly flexibility. Like any other programming language, you have a hard time managing your own memory. But if you want that control, then C++ is the good way to go about it. So yeah, it's a trade-off between extra complexity, but also extra flexibility. If it's worth learning it, it depends on what you're making. I mean, I'm making a game engine. Game engines are supposed to be fast. They need to manage their memory very closely because we need to run it on whatever console we have, whatever computer we have. So everything needs to be managed very closely. Whereas if you're making like any other desktop application, it's probably not needed and you can get away with C#, which does it all for you, makes it easier to implement. But then again, it gives less flexibility when it comes to memory management and all the low-level stuff where you need to talk to your operating system. Okay, I want to check what it does because we have memory operators here, right? So if we go to our shader file, which I've lost. This one. We have a delete here and we have an allocate here. I want to see how much it is allocating or deallocating, because I have a feeling. Where are you? Okay, right here. I have a feeling it is allocating and deallocating less. So let's put our breakpoint in our allocate. I'm pretty sure it's using this one or the other one. So this to that. So now how much are we? We are allocating 64. Remember that, allocating 64. Committing that to memory. Okay, we got this. We're closing it now. We're going to delete that. If we go back to our memory allocators, we're going back to our deletes. How many are we deallocating? We're allocating 8. That's so wrong. Are we using the wrong deletes here? Maybe our delete is wrong. Okay. I've uploaded a C++ game engine just to see if it goes, because I have no idea how it works. So I'm pretty sure it's not gonna be optimized. If it's for a small game, it's fine. But you're probably gonna have memory leaks. Because Cloud doesn't care about it. At the end of your program, you're just gonna release it back to the operating system anyway, but it's good to keep track of it. Okay. So something is going wrong here, because our size is 8, which is the size of our pointer. Let's go to the documentation for the delete operator. How do we implement this? We call free on the pointer size. Okay. Interesting. Delete, puts that, yeah, okay. So track allocated memory from new. I'm pretty sure, so the allocation size was it's gonna do it this way. Okay. Yeah, no, that's not what we want. C++. Okay. Track memory allocations. That's not what I want. The issue is with the delete operator for somehow. Okay, keep a track of operator delete. Memory minus equals static cost size p pointer of -1. That is so sketchy, we're not doing that. It's counting the number of allocations, that's also an option. How does the delete? No, it depends. Okay. So do we have to store the size? Memory tracker. Let's see what this one does. Okay, so for the new and the delete. Okay, this is gonna be seeing how we do it. Empty new size file line. Okay, this is allocating. Delete arrays, delete pointer, yes. Okay, so it's just deleting that and deleting that, yeah. You don't care about the size for some reason? Okay. So you're not tracking the bytes. Okay. Yeah. Not what I want. Okay. Let's check out what journal does then. I will do it on a separate tab though. I'm sorry. I will let you. Here you go. You can just look at a line dialog for a bit. Damn. Okay. Introduction, memory allocation basics, game engine memory allocation. Size new, delete. Yeah. Delete memory size stay. Okay, freeing. Total freed, yeah. Print new, memory allocation. Yes. But that's just... Hold on. That's not the string one. What? Come on. Okay, trickier. Wasn't expecting that. We could, but that's bad as well. We could just track allocations. But these are the important ones. These are the big ones. We need to know the size. But we don't. We can kind of get around that somehow. Actually, we could definitely get around it. Because delete the size doesn't care. So we could do delete array and then do it size of, technically. So we can do something. Oh boy. Why is it just not the allocation of byte? I need the array count here, basically, for it to track it correctly. But I don't know that count. So how do I store the count? No clue. I could save. Wait, hold on. You give contests on code forces? No, I don't even know what that is. Okay, I have an ID. It is very stupid though. I'm not sure if I should do it actually. Because that's probably a bad idea. See, we need to store an extra variable basically. The only way we can do that is by allocating a bit more. But I think it's fine. So I do know lead code, but I don't use it. So for new operations here, what we're gonna do is we're gonna actually store count plus size of size t. Now we need to shift it. Oh, that's a bit bad. Okay, so this is gonna look very, very weird. Okay, but what we're gonna do is we're gonna get the pointer ptr equals, oh yeah, wait, what do we call it? Total count. Okay, so we're gonna make a size there, which is total count, which is gonna be Unity junior programmer for Unity game engine, and yeah, that's cool. It's very cool. It's count plus size of size t. Very sketchy thing. Now we're gonna allocate with the total count. Right. And then we're gonna do a mem copy to pointer. Source is count, which is a pointer of count. Oh, sorry, the address of count with the size of size t. No, I don't need to do that. I need to do that. Mem copy like that. Okay, so now we've copied it. Should get a buzz cut? No. So basically what we did now is we put our size in front of our actual allocation. So the only thing we need to do now is sketchily move the pointer over. So the pointer is actually the pointer plus size of size there, I guess. Yeah. There we go. That is very sketchy. I will put a breakpoint in here because I need to check this if this is correct. And then on our, this is our new. Okay, we should have another new, right? But this will call, yeah, we need to do the kind of the same thing here. So let's do that. Put it here. Oh no, actually we can do way better way of doing it this way. Oops, we will just put the brackets here and then we'll go to the bracket one. Same here, we will go to the bracketed one. I think there's one more. 1, 2, 3, 4. This one. So that's brackets, that's brackets, that's brackets. Wait, that is the correct one. Oops, no, wait, we need to move all of this code. Copy it. Well, actually yoink it and put it in here. And then we yoink this. Put it in here. Make this Al for alignment. And then copy it in here. Okay, that's our new fix. Let's actually see if that's correct. So let's do that. We still have our breakpoint here, but let's put our breakpoint in this one. Then run and let's see. So we should get in there at some point. Oops, unknown size. Size of char. Plus, no, it's just to plus. Oh, we need to cast to a char pointer, I guess. Okay, this is very sketchy. We cast it to a char pointer to then cast it back to a void pointer probably, but that's fine. Recursive on our control path. This one. Oh, this is not operator new. Wait, hold on. Al. Oh, that's not a tag, so we need to copy this. Paste it in here. Oh yeah, we need to do it twice. I forgot about that. Is this the one with the tag? This is the one with alignment. Right, okay, so to that. Like this. Compile. Okay, run. So we need to put our breakpoints. Oof, I think that was just in time. Yeah, we got our breakpoint in here. So we have a count of 24. Wait, what are we allocating? We reallocate to a count of 2, and we are allocating, what are we allocating? I don't know what D is in this case. Render target, and render target is 8. So where are we? Count was 24 for some reason, probably because we doubled it or something. So then total count should be 32. We allocate a pointer of 32, which is at F0, and that should be shifted by 8. 8 is 8, so it should be F8 at the end. Did we return? Can we see what we returned? Apparently not. Oh god. Oh, not sure if that's correct. I think that was shifted by way too much. I will find out. Oh, seems correct. And then the delete. Ooh, yeah. We need to fix that. Okay. So the delete. Okay, very simple fix for the delete. I think we only have to fix it. Oh no, we have to fix it for all of these. So first of all of these should go through their variant for this one. Okay. And then this one needs to go to that one. Okay, so that's correct. But before we do that, this pointer is actually wrong. We need to minus that pointer. Okay, this is sketchy. So we know how I stored it in front. We should set the size to whatever is in front of our pointer. So we need to shift our pointer. Okay, so let's get the actual pointer. Actual pointer equals a chart pointer minus the size of size t. Yo, welcome. We're doing some very sketchy hacking here, and then we're gonna get size t total count equals actual pointer, size t pointer. Actual pointer 0. Well, we can actually just dereference it. And then that's the total count. Sketchy. Just how I like it. Okay, so we don't use that one. Yeah, that's correct. Memory allocations in a bad way. Okay, so we allocate this, which is fine. And we close it. We get in this one. So we got our pointer. We're gonna move that up by, pretty sure it's gonna be like 8 bytes. So we need to be at, I think 0, which is correct. Then we get a count. 64, and then we deallocate that with our total count, which should be fine. No, we still have 16 bytes in memory leaks. How? Okay, okay, let's I'm gonna print out how the allocate and the deallocate goes. I mean, it's better. We're getting there. I'm not sure. Actually, wait, we're saving the count, but we're allocating more. That might be the issue. Hold on a second. Okay. I'm pretty sure I know what the actual issue is. Because total count is that plus... Well, no. We just need to do... Do we actually use it? Yeah, we use it. Okay, so let's do... Here, total count is that plus size of... size t. And that should work. Probably. Okay, so let's do that. Continue. We still got a triangle. That's not disappeared. And then no memory leaks. We fixed it. We fixed the single memory leak and our memory tracker. So this is very sketchy. Okay, this is I don't know if we should actually do this or not, but what we're doing, so basically what we're doing is we are requesting some amount of memory from the operating system to put our data in. And then what I'm doing is, because I need it, is when we make an array of, well, when we make an array of that, I'm actually putting the size in front of how many bytes I'm gonna allocate. And then on delete, I'm getting that whole pointer again, getting the size, and then clearing the whole thing. This is so sketchy, but it works. I love it. Oh, this is great. Okay, so that's memory allocation done. Memory leak detection done. Let's actually make a commit for this, because that's actually fun. There's version files as well. Makes sense, makes sense. So we're gonna do that, and then we're gonna say edit memory leak detection. Go ahead and push. There we go. Yes, push to the main branch. There we go. That was so fun. I don't know if there's actually a better way of doing it, because we don't get this in here, and then we also have to worry about MSVC. It's great. It's fun. Also, I don't understand why MSVC does it this way. So basically they do their own aligned malloc and their own aligned free, but they use the same parameters as the standard library uses. So how? How does it work? How could it not use the same ones? I do have yeah, it's fine. And then all the C++ style casts, I'm actually fine with type when aligned. That's actually a good question. That's actually a good one. Let's do that, and that. And then in here we will need to remove all the aligned macros that I did because I was lazy. I'll be very honest. And then we need to undefine them, because I don't want to find them anywhere else in my codebase. Whew, okay, and then if we actually include memory operators, we get these. Technically we don't need these, but I like it, because we could then in the future add like a delete tagged with a tag, and then we could call delete with a tag, which is nice. Same for the new. So then we can have groups of memory basically, so we can see how much memory we spend on our rendering, how much we spend on our game data, how much we spend on whatever we want, right? Now we don't have that. Why is the inversion file still not in there? I did add that to my last commit, no? Edit memory manager. Push. No, push. Push anyway. I thought I did that already. Okay, anyway. I don't need to worry about broken builds on GitHub because I don't have a full release thing yet up. So, okay. Next thing on our to-do list. Are we gonna do it? Probably not. But we can talk about it. It's proper synchronization. I don't... Okay. So, we still need a fence class. That's basically the only thing we need. If we have this and maybe a resource barrier, we have a command list. So we can remove that. These three. These things. If you have this set up, all of these set up, then we're basically done with our rendering API for a minute. Well, technically we could also start rendering 3D, but I don't want to worry about 3D yet. After that, I want to break from rendering. I want to talk about ECS. And then, or we could do that first. We'll see. I have them all down here, but basically this is it. Yeah, I think that's gonna do it though. We got our memory operators sorted out. It took a whole stream to implement, what is it, 12 plus another 12 plus another 4. So that's 12 and 16 is 28 functions. And they're not implemented, probably not implemented in the best way, because we chain them, which is probably not the best way of doing it. But I'm fine with it. I could also actually, might be even better, but it's kind of the same thing. Let's just write an allocate and a deallocate. And then allocate array and deallocate array. Actually, let's do that way. Let's do it that way. That might be cleaner. So in our memory operators, in here, we are going to have a namespace. We're gonna call it, we don't have anything in here, and we're gonna do a void pointer, allocate. And then, no, just do it this way. And then we're gonna have a void deallocate. I don't know how that happened. And this can't be, no, there can't be no accept. So we're gonna have allocate, which just has a size account. It takes account, and it takes an aligned variable. Right, yes. And then it takes a null throw tag. Does it take a null throw tag? I don't know. Actually, we don't need to worry about that. We can just do a throw exception. Gonna call it false, right? And then this aligned variable alignment equals, we're gonna put a const expr default alignment, which is gonna be a global alignment value. There we go. Gonna do that in here. Whoops. There we go. So then we have allocate, and what will allocate do? It will do this. I'll put that in here. And then if throws exception, then we're gonna throw the exception as well. Simple as that. That's our whole function for allocate. It's gonna complain that we're not locating anything, so we're gonna do return allocate. and then we just do count. And then we're gonna do return allocate here as well. But we're gonna make an allocate array, I think, which will do the array hacking. Array. And this will do the array hacking, which is this. Allocate. Count. All of that. Total count, sorry. There we go, and that's actually... is that all fine? It should be all fine. Okay, so allocate. This is allocate array. So we're just cleaning it up a little bit. There we go. This is allocate again. But then with a count. And an alignment value. This is this one again. With allocate and an alignment value. And then these are the same ones. But with no accept. So can I just actually do this? I'm not sure that will compile. Because it will still throw exceptions, which it shouldn't. So we probably need to do... I mean, it's stupid to do this, right? With the default alignment. Oh, it's a bit annoying. Okay, let's figure that out in a bit. Why is this still... Not all control pods return a value. Oh yeah, return no point. Correct. Thank you very much. Let's allocate. Did I misspell alignment again? Default align. Oops. Right, so we allocate it here with the alignment. Deallocate. Okay, allocate. I don't know about these no accepts. Okay, so let's see. What does no accept do? Can I call a no accept? If the expression is function is declared as do not ranks f following is always part of its form. Same as no except true. Okay, so throw is not allowed anymore, which is good because we didn't implement those functions. Enough expression is not a part of a function, just like it can only appear as part of a lambda calculator. Yeah. Every function is either non-throwing or potential throwing functions. So can I... Okay, so I can non-throwing are permitted to call potential throwing functions whenever an exception is thrown in search of the handling account as almost blocks non-throwing exception. The function terminate is called. Okay, so we just terminate instead of throwing an exception, which I'm fine with. Okay, so we don't need this last bool. Great. Actually, yeah. No, if we do run into it, we will throw the exception. And this will allow us to catch it first, right? So that's all fine. And these will need to no accept, but it will just call whatever. Great. So this will just return allocate counts. And this is gonna be allocate count again, but this one is gonna be allocate array, and this is gonna be allocate count all. Return, idiot. And then same one here. There we go. And then we're gonna do all. And tag never used. Okay. Tag not used. Great. Good. Allocate delete now. So we need to do the deallocate, which we've implemented twice, right? We've got the deallocate the normal one. Just this. If the pointer is null, we return. Otherwise, we decrease by size the count. And now we free. Yes. There we go. Perfectly fine. And why did we make that no accept? That shouldn't be no accept. Delete. So deallocates. Counts. Size. Okay. Deallocate. And then we also need to do a deallocate array. Which will be the tricky one again. So that's this one. Boop. Okay, actual pointer is that minus size of d. Size equals dereferencing it, and then deallocate, we don't need the alignment. Oh no, we do need the alignment, don't we? Everything is aligned, right? Yeah, we align everything, so we always need to do align free, but that's actually fine. We just call deallocate with actual pointer and total counts. No, count. No, total count. That's correct. Don't change your mind like 17 times. Okay, that in there, and then pointer. There we go. And then that one, same here, but with alignment. Oh, we never need the alignment. Okay. Which is very weird that we don't need the alignment. But I'm not questioning it. Pointer and size. There we go. And then this one's exactly the same as this one. And then this one, same deal here. Just do that. Size. And then boom, done. There we go. Apparently we don't need to size here. Count. Yeah, we don't need count. Oh, well. I'm just gonna leave it like that. Actually, no. Let's just remove it. We don't need it. Because we know for a fact where the size is. Good. Done. If we compile it now, it should still all work. There we go. We run it. We still should not have memory leaks because it's still the same code. There we go. Bosh, done. I'm actually happy with this. This is what we should have accomplished last week though. So we're a little bit behind schedule. I don't really have a schedule, but hey. There we go. I think that's it. So let's say clean up. Memory operators. There we go. Come in and push. Yes. Done. Push. Great. Damn, I liked it. That's good. That was fun. And I think with that, we can call it a day. I think that's a nice little ending, and then next week we can look at some graphic stuff again. And then after that, hopefully CS. Hopefully. But yeah, this is what we have still. Same old triangle, but now without memory leaks. Guaranteed. Guaranteed, because I have DirectX memory leak detection turned on. I have my own memory leak detection on all the data I create. So we're golden. We're great. It's gonna be perfect. Okay, that's about it. That was it for this stream. I think it was successful. Way better than last week, because I struggled last week, damn. Either way, there's gonna be like an eclipse tomorrow, which I might look at. That might be interesting. Apparently it's not gonna happen where I'm at in my part of the world for another like 60 years, 70 years, I think. It's gonna be a while, so there's no guarantee I'll see it in my lifetime. So if I can get to it, I'll try. But I mean, I think that's about it. Yeah, successful stream. We got everything figured out. We got our trusty triangle here, and yeah, I'll see you all next week, same time, same day. And then we'll talk about some graphics stuff. Okay, goodbye. Shoot, I forgot. I always need to press the button twice. Okay, there we go. Now it's goodbye.